Okay. Let's get started. So welcome everybody. This is a little lamb makerspace. We're looking at healthcare chatbots. The ultimate goal is to provide some chatbots that either doctor or researchers can use to interact with X-ray scans and report to be able to answer questions they have while they're doing diagnosis and or research in general, essentially. My name is Fabio. I lead the engineering team at Hopsworks. Hopsworks is an AI lakehouse platform that allows you to kind of build out machine learning and AI systems, including Gen AI systems, in real-time, batch, and so on. Right. So as I said, the goal is we start with the data itself, right? So the underlying idea is that we have access to a bunch of like chest X-rays in a image format, right? And we also have access to some of the reports that have been compiled by the X-ray technicians, essentially, right? So the idea is to be able to, in the first pass, to be able to understand what these models, what these images are, and what they contain, and what's the likelihood of disease that they contain, if any. There are obviously some images that people are completely healthy, and in the second step is to be able to kind of be able to query this knowledge using a chatbot built leveraging things like large language models and function calling. Right. So how do we get from PNG images of X-rays to the underlying to the understanding these images and understanding this the different aspects, right? So before doing that, actually, one second. The idea behind it is like what kind of answers, what kind of questions, right? The chatbot should be able to answer, right? Then we kind of build it from that point, right? The basic idea is that you go through kind of a set of steps, right? You first detect the symptoms, then use a condition. You make a estimate guess on what's going to be the prognosis and what's the best way to treat the condition. There are a couple of different questions. The chatbot has actually two different use cases and two different personas that we want to help out. One is the doctor persona. So they're looking at specific X-ray of a specific patient or specific X-rays of in a specific groups of things, right? The researchers actually take a more like a broader approach, right? They've been looking at things like can you give me back a sample of all the images that contain a specific condition, or where does the report, if you remember earlier, let me just move this one a little bit away. If you remember earlier, we have images that have images and reports. So what kind of information that the reports do not match the X-rays and things like this, right? So this is kind of the ultimate goal of the chatbot, be able to answer this type of questions. And the way we build it using three different technologies. Actually, one is Hopsworks. So as I said, Hopsworks is a AI lakehouse platform that allow you to build and deploy AI systems, train and deploy AI systems, both for traditional machine learning, but also for, let's say, Gen AI applications. So we're using large language models. There are a set of tools and capabilities that are included in the platform from, be able to track and version everything, like from, the different inputs of different models, different types of embeddings that you're computing on the different data, things like version, the responses of the users and pipelines and so on, right? So that's one key item when also building a Gen AI application that you should be focusing on. The other aspect is Hopsworks provides different ways of computing and storing features and computing and storing data ultimately. That allows us to be able to build real-time GenAI applications, right? So you will see in a moment when we ask the model to say, okay, give me back, the X-ray for patient X, for instance, right? That patient, the X-ray gets retrieved in real time thanks to the extreme performance of the underlying storage. That is our online feature store, essentially. And there are a couple of other aspects, especially when it comes to enterprise focus, and especially when it comes to this type of very sensitive use cases. We're dealing with medical data. Hopsworks provides deployment, on the cloud, but also on-prem. We have audit reports looking at, what kind of access has been given to different users, to different components of the platform, and so on, as well as be able to track and have very lockdown permissions on being able to access only certain data for only certain type of use cases. The other items are as Hopsworks has recently joined a partnership with NVIDIA. So we leverage some of the NVIDIA technologies to build this chatbot underneath. One is the MONAI framework. MONAI framework is a deep learning framework for doing research and building applications on top of medical data, in particular around vision data, so and around images and so on. So this is a good example, the chest X-ray. There's an open source version of it, and there is also an enterprise version of it that NVIDIA has. In particular, we're going to be using a model called TransCheX, which is it's a model that basically takes as input the NVIDIA, sorry, the X-ray in PNG format, and the report is a multimodal model, and then be able to make a prediction on a set of classes and where things are in terms of what's the most likely disease that the X-ray contains, right? That's one item and one component that we work with from NVIDIA. The other component is NVIDIA NIM. This is a new technology that NVIDIA has recently announced. That's a microservice that you can deploy both on the cloud and on-prem, as part of it's integrated with Hopsworks, and you can basically use it to deploy a large language model again within your environment, right, without using any external cloud providers like ChatGPT and things like this, but have full control over the LLM and the data that gets sent to the LLM and what does the LLM do with that, essentially, right? So the basic idea is that you have this microservices architecture that gets deployed, and you can integrate it with the Hopsworks platform, right? So these are the two NVIDIA technology, right? So let me jump into the demo. I'm going to show at the end then kind of where we built it from there, right? Let me just do this. Okay, yeah. So as I said, there are essentially two main use cases that we want to cover with this chatbot. We have a doctor copilot, and we have a researcher copilot. The idea is that you help doctors kind of predict faster and have faster insights on the underlying reports and output and things like this. So one of the questions that we had that we want to be able to answer this is, how do we, for instance, if there is any trace of cancer in the X-ray for patient 516, right? So what that actually means and what's actually transformed is a couple of different things behind the scene to be able to actually answer. So this is the answer from the model. It's basically saying, based on the prediction of the TransCheX model, there's no likelihood of cancer. It's actually this scan is clean for cancer. But the way the model comes to this conclusion is in a set of steps, actually, right? So let me actually go back and show it in a little bit of the architecture diagram, right? So what basically happens behind the scene is that the doctor, in this case, or the researcher in the next case, talks to the NVIDIA NIM, right? The NVIDIA NIM is, in this case, is leveraging the Llama model, right? So there are different NIMs for different models. In this case, we're using the Llama one. what happens is that from the question, it extracts the most relevant questions through a process called like function calling. We have registered all the functions that we need to be able to operate and answer all the questions that the doctor might have around the X-rays. Those questions and those functions are managed by Hopsworks, and they are registered with Hopsworks as part of the versioning scheme that we were mentioning earlier, to be able to make sure that we know exactly what kind of questions the chatbot can answer, and what kind of functions, and the description of the function and things like this. So what basically happens in this case, we look back at the question itself. We're going to extract this patient 516. 516 is the ID of the patient. Again, this is something that it's extremely confidential. I mean, we're not going to use the service social security number. Just going to replace it with an ID to avoid any troubles with different regulations and rules and so on. Once the NVIDIA name and the LLM underneath kind of extracted the relevant functions that we need to invoke, and the function and the parameters that are needed for that specific function, then we can use Hopsworks to leverage and be able to kind of augment the information for creating a better prompt to be able to answer that question to the doctor, right? So in Hopsworks, we have different sets of items that we can leverage, and different set of storages and real-time models that we can leverage to be able to make those predictions, right? So one item is this TransCheX model. This is the live model that has been trained on Hopsworks and is available as part of the Hopsworks platform, where we can basically use it to make real-time predictions, right? But sometimes it's easier to pre-make these predictions, and every time a new X-ray comes in, we want to be able to make those predictions, and we want to be able to kind of store those predictions and be able to retrieve them in real time. This is the way we actually have done it. We have, as new X-ray and reports come in, we have created a table, which is all my outcomes, right? Which is basically for every patient, we have a set of possible outcomes that the TransCheX model predicts, right? Whether it's whether it's fracture, whether it's lung lesions, whether it's pneumonia, and so on and so forth, or whether it's just nothing, no findings, for instance. In that specific case, this data is available with extremely low latency, think like low millisecond latency, so that we can immediately answer the question as soon as the doctor asks the question, essentially. And the nice part about it is that we use Hopsworks both as a storage for the structured data, but we're also using Hopsworks for storage for unstructured data, right? In this case, we have two types of unstructured data. We have the medical images themselves, right? So in this case, we are using the medical images as a way to make predictions, right? So that's part of the input to the TransCheX model. But we're also using the medical images as a way of presenting the output, right? So what happens is that as part of the function calling, one of the things that the model does, one of the functions the model invoke, is be able to retrieve the image associated with this specific patient and this specific outcome, right? So so this is basically one of the items. The other items that we can actually invoke, this is more on the research side, is actually the vector index, right? So we can ask questions about things like, okay, give me back all the reports that have specific findings, or they have a specific combination of findings and things like that. This is possible because we provide a vector index as part of the Hopsworks platform that allows you to do similarity search and allows you to basically do to be able to retrieve similar reports or similar images and so on. Right, and this also applies to obviously images as well, as long as you compute the embeddings of the images and so on. Once the appropriate function has been called, Then the outputs is retrieved, as I said, with a strong focus on the real-time aspect of it. And then the function is given back to the context, the additional context retrieved by from Hopsworks is then given back to the NIM to be able to generate an appropriate response, right? In this case, we are, we have retrieved all the outcomes and so on, and we're basically giving back and ask the LLM to be able to figure out what kind of disease there is, and what's the most likelihood. Either if there is an disease and exclude it, we can also do it the opposite way. We can also ask, what kind of disease it's most likely, right? Things like that. So this is for the doctor copilots, and there are more questions and things like this that you can answer. The other item is the research copilot, right? The research copilot actually does something different. As we said earlier on, the research copilot is more helping researcher kind of navigating the data. You have tons of data across with different in different formats, in images, data, structural data, that we have the outcomes, we have the reports in text format, and want to be able to kind of query that data in a chat fashion, and to be able to kind of make sense or retrieve the information that they're looking for that specific moment, essentially, right? Without them having to sort out and do any analysis and things like that. So in this case, the copilot is asking something like, can you provide some images for cardiomyopathy? Which is like a condition where the art size is bigger, and you can actually see it in the first picture, where the art size is probably bigger than normal. The idea, again, it's the following: the X-ray have been parsed, and the specific disease has been predicted by the MONAI framework, the TransCheX model from the MONAI framework, and it's part of the outcomes that we provide. So when we ask the question, then a set of images get kind of retrieved, and you can basically see all the list of the images and so on. You can ask a bunch of different questions, follow up, and so on. So these are the kind of the two items, the two copilots that we can actually do it. I think, let me see if this is still running. A second. Actually, running in real time. Let me just stop it in a second. And you can see that the time it takes for going and retrieving the images and loading up the images and so on. It's mostly just downloading the images that's taking time. Prediction has already been made, and they are available in low latency online page store that we can actually query and use to be able to make to be able to answer these questions from the LLM. Now there are a couple of other items that are kind of really key here in terms of what kind of values what kind of tools you can use from Hopsworks that you can make it very easy to actually kind of build that specific items, right? One is, as we said, all the feature data, all the signals to the model, whether it's a specific deep learning model, the TransCheX model that is being used for making the predictions, but also using the same input or the output of that model as a way to inform the description of the chatbot and inform the answer of the chatbot. Function registry, be able to store all the configuration for all the different functions that can be provided to the model and can be registered with the model when it's time to actually build and use the chatbot. So again, this goes back to, and it's also highlighted the last point. It goes back to be able to control which functions are there, be able to determine which version of the function was used for this specific chatbot. And it's also useful when you do debugging of that model, right? So if you get reports of the chatbot is not functioning correctly, or it's not giving back a specific answer correctly, you can basically trace back which embeddings model you were using, the way like different chunking strategies you might be using, different functions and definition of those functions and input parameters of these functions you were using, whether or not you were using the vector index, the line feature store, or other underlying sources like we're seeing in a second. So all of this is being able to track through the versioning scheme in Hopsworks, right? We have we have a concept of splitting up the different pipelines into like individual chunks. We call them feature training and inference pipelines. Feature pipelines, again, we take the different items, right? The different raw data sources, the images, and we put them into a vector format to be able to use the TransCheX model. We clean up all the predictions, and we basically populate all the and pre-compute all the features that are needed for the chatbot or the specific underlying model. Again, training pipeline. We haven't done any fine tuning at this stage on this model. We're just using the NIM models as it is, but Hopsworks can be used as a way to fine tuning the specific model. So there are a bunch of open source models. The Llama model being one of them that you can actually use to fine tune and make sure that it understands the medical jargon and the different subtles like acronyms and things like this that are part of the day-to-day operation of a doctor or medical research and so on. And then finally, the inference pipelines, what we were showing earlier, be able to kind of build out all the chatbot interactions, be able to kind of load up all the feature data that's needed to be able to build the prompts and be able to make predictions, as well all the functions that are needed for invoking the different underlying data sources and so on. Last one. There's one additional items that we're working on in the background. One of the things that we're working on is to be able to introduce a knowledge graph. We take advantage of the knowledge graph to be able to do similarity search across images. So in the next iteration of the chatbot, the researcher will be able to say, okay, given this image, can you give me back similar images and the appropriate report that is based on the knowledge graph. And again, from an Hopsworks perspective, what that looks like is basically adding another arrow here at this level, where it's another type of function that the LLM can invoke for looking at things like doing queries on knowledge graphs and be able to kind of retrieve similar items and similar aspects. Yeah, that's everything I have for today on the chatbots. If you have any question, I think the Q&A is open. Otherwise, feel free to reach out in the background.